Okay, so for these first three, we're asked to convert them into fractions. 475%. Anybody want to share what they got for a fraction? 4 and 3/4. Perfect. So you make that 475 over 100, and that reduces to 4 and 3/4. 73 and 1/3 percent. Anybody share what they got with that for a fraction? That was a little tougher, isn't it? So that one's 73 and 1/3 over 100. And probably the easiest way to handle that is to just divide it out. So 73 and 1/3 divided by 100. And we'll leave that answer in a fractional form. So we got 73 times 3 is 219, plus 1 is 220, over 3. Now divided by 100 over 1 is going to be times 1 over 100. So we're going to cross cancel the 220 and the 100, both divide by 10. So 100 divided by 10 is 10. 220 divided by 10 is 22. So now I've got 22 times 1 is 22. And 3 times 10 is 30. So that is 22 thirtieths, which divides out to be 11 fifteenths. So I guess I could have taken a 20 out of each of those instead of just a 10. Did anybody get 11 fifteenths for that one? A few of you? Good. That was a tough one. How about the 18.75%? Anybody want to share their answer for that one?
3/16.
3/16 is perfect. That's 18.75 over 100. And since there's two decimal places, we'd multiply by 100 to get rid of the decimal in the fraction. So 1,875 over 10,000, which does reduce to 3/16. Good job. On the other side over here, 2.6 as a percent. Who wants to share what they got for a percent? Go ahead. 2 3/5 would be as a fraction. Now to take it that next step to a percent.
260%.
260%. Very good. You're in the right track. Good. So now the 2 3/8. Anybody want to share what they got? What I would do with that is I would convert it. We're good. Yep. I would convert it into an improper fraction. 2 times 8 is 16, plus 3 is 19/8. And then we know that that's 19 out of 8, and a percent is always out of 100. We can cross multiply and divide. 19 times 100 divided by 8 is 237.5. So that's 237.5%. Or you could have just divided out the 3/8 to get 0.375, so that's 2.375, and move the decimal point over 2 spots to make it a percent. And for our last one, 0.071. Anybody want to give me what they got for a percent for that one? So what was that?
7.1%.
7.1%. Good. Good job. Okay, we left off last class talking about benchmarks and using benchmarks to estimate percents. Like if we were asked to find, let's just say 49% of 2,389. Well, what I would do is I would basically say, 2,389 is about 2,400. 49%, I probably wouldn't even work it out. I would say that's just 50%. But let's, for the sake of it, say that is 50% minus 1%, to be a little more precise. 50% of 2,400 is just half, so it's 1,200. 1% is just moving the decimal over 2 spots, that's 24. So 1,200 minus 24, we're looking for something around 1,176. So we have those estimates. In fact, I would have probably just, like I had mentioned, probably say, 50% is about 1,200. 49% better be smaller than that. I'm looking for something a little smaller than 1,200. So today we're going to start in with exact calculations with that, which I know you guys have all seen before, but we're going to ramp it up to some more difficult applications before we're done. So let's say that we are asked to find %37 of 210. Well, when we are asked a question like this, we always start out, or I always start out with the percent. 37% is 37 out of 100. And once we've done that, once we've expressed the percent like that, the rest of the problem becomes just matching things up in a proportion. So find 37%. There are two other numbers here. One number corresponds to the 37, one number corresponds to the 100. So it's key to understand what each of those means. The 100 on the bottom here, 37%, we think of that as 37 out of 100. Just that phrasing implies that the 100 is a whole group or a whole amount. Sometimes it's thought of as the starting amount or beginning amount. It is what we are basing our calculations off of. So 37 out of 100 implies that the 37 is a piece or a portion of a whole amount that we are looking to focus on. So now, to fill in the rest of this proportion, we have two other numbers. We have the 210, and we have the number that we are looking to find. One of them matches up with that portion that we're looking to focus on, that's the 37. One of them matches up with the whole amount, which is the 100. Well, when I read this, whenever I see of 210, I read it as out of 210, which implies the 210 goes on the bottom of that other ratio. And to find that missing number, we're just going to cross multiply and divide. 37 times 200 divided by 100. So 37 times 210 divided by 100 is 77.7. So 37% of 210 is 77.7. We might be asked, blank is 130% of 60. So again, we start with a percent. 130% is 130 out of 100. On the other side, well, blank is 130. That implies the blank goes with the 130 of 60. Once again, if I read that as out of 60, it implies the 60 goes on bottom. So a cross multiply and divide. 130 times 60 divided by 100. 130 times 60 is 7,800. Divided by 100 is 78. So 78 is 130% of 60. You'll notice here the piece that we're focusing on is bigger than the whole amount or bigger than the base amount. That's because our percent is bigger than 100. 100% is one or one whole thing. We might word this a little differently. We might say 23% of 50 is blank. So here again, we're going to start with our percent. 23% is 23 out of 100. Now the of 50, if we read that as out of 50 again, implies that the 50 goes on bottom. And we once again cross multiply and divide. 23 times 50 is 1,150 divided by 100 is 11.5. So 23% of 50 is 11.5. So let's look at one like this. Let's say that we have 63 is 90% of blank. Well, we're missing some different information now, but we still have the percent. So we're going to start out 90% is 90 out of 100. This time, however, 63 is 90%, so that implies the 63 goes with the 90 of blank. Again, if I read that as out of blank, implies that missing number goes on bottom. So now we will cross multiply and divide. Notice we're cross multiplying a different direction now because this is the diagonal that has both numbers. 100 times 63 is 6,300. We divide by the 90, gives us 70. So 63 is 90% of 70. We might have 15% of blank is 45. So same thing, we're going to start out with a percent. 15% is 15 out of 100. Now we have the missing number and we have the 45 of blank. If we read that as out of blank, implies that missing number goes on bottom. So the 45 goes on top. Cross multiply and divide. 100 times 45 is 4,500. Divided by 15 is 300. So 15% of 300 is 45. So now we can look at one just a little bit different again. It might be 32 is blank percent of 80. So for all the problems we've done so far, we started out with the percent. Here, however, we don't have the percent, but I am still going to start with it. Blank percent, blank over 100. Well, 32 is blank percent. That implies the 32 matches up with my missing percent of 80. If I read that as out of 80 again, implies the 80 goes on bottom. Now here I'm still cross multiplying along that diagonal. 100 times 32 is 3,200. I'm just dividing by the number down in this corner. Divided by 80 gives us 40. So 40 out of 100 or 40%. 32 is 40% of 80. We might have blank percent of 70 is 14. So same thing, we're missing the percent, so it's blank over 100. Well, I see of 70. Again, I read that as blank percent out of 70. Implies the 70 is on bottom. So the 14 must be on top. And we cross multiply and divide. 100 times 14 is 1,400. Divided by 70 is 20. So 20% of 70 is 14. I like this proportion method simply because it's just a matter of matching up the numbers and getting them in the proportion. And once they're in there, it's always the same calculation. Cross multiply and divide. Now you might cross multiply a different direction, but it's always cross multiply and divide. Some of you may have been taught or may have seen a method called the rate method of percents. Excuse me. A rate is another name for the decimal form of a percent. So 37% as a rate would be 0.37. You just convert your percent to a decimal. And using the rate method of percents, you convert your percent to a decimal. So for this problem, it would be then 210 times 0.37, which is 77.7. Or for this next one, 130% as a decimal is 1.3. 60 times 1.3 is 78, which is our answer. Now that looks very simple, and for this type of problem it is. The problem is, let's go down to this one here. 63 is 90% of blank. Well, 90% is 0.9 as a decimal, but it is not 63 times 0.9. In this problem, you'd do 63 divided by 0.9, gives you an answer of 70. Same with this one. 15% is 0.15. It would be 45 divided by 0.15 to give you 300. So if you're using that rate method, you change your percent to a decimal, but then you have to decide, do I multiply by it or divide by it? And you can run into a third type, which is this one, where you're missing the percent. So then you have to take the numbers. 32 divided by 80 is 0.4. Then you have to move the decimal afterwards to get the percent, 40%. The rate method is quicker. In fact, it's the way I do most of my percents when I'm calculating in my head, because it is a little quicker and easier to calculate. But it's also easier to make a mistake because you do have to decide, do I multiply, do I divide, do I move the decimal point first, or do I move the decimal point at the end of the problem? So for simple percents, this proportion method usually produces a lot less mistakes. However, as we get up into more of our complex applications, there are a lot of applications where the rate method is very useful. It's a lot quicker and more useful for us. It's handy to have. Let's look at some word problems here right now. Let's start with a simple one. Let's say PFM Corp estimates monthly profit as 12% of gross sales. Find the gross sales in a month where profit is estimated as $387,740. So here we have a percent. We have the 12%. So I'm going to write that, 12 over 100. Now, the 100 represents a whole pool, a whole population that we're trying to draw from. And the 12 represents a piece of that we're looking to zero in on or to focus on. In this problem, there are two things that we have. We have profit, monthly profit, and gross sales. Which one does the 12 represent, the monthly profit or gross sales? Monthly profit as 12%. Think that is 12% of gross sales and is out of gross sales. So the 12% is the profit. The 100 is the gross sales. The gross sales is the bigger pool that we're looking at, and we're focusing in on 12% of that to be our profit. So once we've labeled our percent, once we know what the numbers mean within our percent, the rest of the problem comes together. We have 387,740. Does that represent profit or gross sales? Profit is estimated as 387,000. That represents our profit. So now we solve this, cross multiply and divide. 100 times 387,740 divided by 12. Should give us 3,231,166 and 67 cents would be our gross sales for the month. Now, are we looking for gross sales? Yeah, find the gross sales. So that is what we're looking for. And with percents, it's a good idea to get used to double checking that. Is what we calculated what we're looking for, or just what we were able to get from our percent? Let me show you what I mean by that. we might have ones like this where we have, let's see. After, let's do the word is a little bit differently. Let's say Pat pays 30% in taxes. If Pat's gross pay for a week is $2,300, how much does Pat keep after taxes? So again, we've got our percent, 30%, 30 over 100. What does the 30 represent here? As you look through the word problem, can anybody pick that out? %, in taxes. The 30 represents the amount of taxes that Pat pays. The 100, the whole pool that we're looking at is Pat's gross pay. So 100 represents gross pay. So now on the other side, do we know either the gross pay or the taxes? Yeah, we know the $2,300. This is Pat's gross pay. So we put 2,300 there. We cross multiply and divide. 300 times 2,300 divided by 100 is going to give us $690. So now the question is that what we're looking for? Well, the $690 represents the taxes that Pat pays. We're not looking for the taxes. We're looking for how much does Pat keep after taxes. So we have to take the $2,300 gross pay, subtract the $690, which is going to put us at $1,610. That is what Pat keeps after taxes. That is the answer to our question. So when we're dealing with these percents, we calculate the numbers, but we have to make sure we go back and double check, is the number we calculated what we are looking for to answer this question, or do we have to do an extra step with it like we did here to find what we're looking for? Okay, now there's a lot of other applications we can look at here. I want to do some increases and decreases here for a minute. Let's see. The doctor orders a 15% decrease in dosage to 680 milliliters per hour. What was the old or original dosage? I want to give you guys a couple minutes, see if you can figure this one out on your own. We're going to talk about it in about a minute. Okay, let's take a look at this one. I forgot they had early release today. So let's take a look at this one. We've got the 15%. So make that 15 over 100. The 15 represents the decrease in dosage. 100%, remember, always represents either the whole thing or the beginning amount. That's the original dosage here. So now as we look at setting this up, we have the 680 milliliters per hour. Is that the decrease or is that the original dosage? It's really easy to call it the decrease. The problem is it isn't either one. That is the new dosage after the decrease. So it doesn't represent either one of these numbers. When we're dealing with percents, there's always some hidden numbers, especially when we have increases or decreases. There's always some hidden numbers in here. So when we have 15%, that's 15 out of 100. But there's always some other possibilities we run into. If it is a decrease, there's 15 or 10, 100 minus 15 is 85% or 85 out of 100. If it is an increase, there's 100 plus 15 or 115 out of 100. Those percents can possibly come into play. Now in this case, it was a decrease. So we're going to try to use 100 minus 15 is 85%. So the 100 still represents the original dose. I'll put it back this way. So that is still representing that original dosage. The 85 now is the original minus the decrease. That is the new dosage. And that is the 680 milliliters per hour. So now to find the original dosage, we can cross multiply and divide. 100 times 680 divided by 85. Gives us 800 milliliters per hour was the original dosage. Did anybody get that one right? Okay. Usually on the first example of those, most people don't get it right anyway. How many of you tried to find 15% of the 680 and add it back on? Okay. And that's the direction most people go with this one, is they try to find 15% and add it on. But you've got to remember, there is something that's represented by that 100%, which is the original dosage in this case. That's what the 15% applies to. So since the 680 is not the original dosage, we cannot apply the 15% to it. Similar to that, let's say that after a 20% increase, a dosage is 840 milligrams per day. How much did it increase? So again, we've got the 20%. The 20 here represents the amount of the increase. 100 represents the original amount again. Well, we are looking for the amount of the increase. But do we know the original amount? Well, the 840 is not the original amount, it is the new amount. Now, since this is an increase, we're going to be doing 100 plus the 20. 100 plus 20 is 120%. So the 100 still represents the original amount. The 120 is the original amount plus the increase. That's the new amount, which is going to be the 840 milligrams per day. So if we cross multiply and divide here, 100 times 840 divided by 120, you get 700 milligrams per day. Now that represents the original amount. Is that what we're looking for? We're asked for how much does it increase. So that's not what we're looking for. We still have to go back and take the new amount minus the original amount to get 140 milligrams per day is the increase. So you have to be very careful with those percents to make sure that what we're calculating is what we're looking for. Now, an application of these percents that I want to go over before we're done, and I might not get through all of it today, so we'll finish it up a little bit on Monday if we have to. Reminder, by the way, Monday we finish up Unit 1, so Wednesday is Unit 1 test. So anyway, looking at interest is going to be a big application of percent. Interest is pretty much everywhere in our lives, whether we're investing or borrowing. We're either collecting or paying interest on something for most of our lives. We're going to start out looking at simple interest. Simple interest is just what it sounds like. It is the simplest way to calculate interest. In simple interest, interest is only calculated in one of two cases. The end of the term. So if it's a 6-month CD, you get the interest at the end of 6 months. Or before any action is taken. So if you pay money into the account, they might calculate the interest before they add the money in. Or if you draw money out, they'll calculate the interest before you draw money out. The formulas for simple interest. The amount of interest, I, that's the dollar amount of interest, is equal to P. P stands for principal. That is your beginning amount or starting amount. So that principal would be your 100% times R, which is a rate. A rate is a percent as a decimal, times T, where T is time in years. So let's say that you put away, you invest $3,000 at 4%. Oh, let's do 8%. Let's make it a little more interesting. Let's go 8% for 4 years. So the amount of interest you're going to earn, I, is the principal. The principal is the starting amount. That's the $3,000 you invested. Times R, your rate. That's 8%, but as a decimal, that would be 0.08 times your time, which is 4 years. If we multiply that out, 3,000 times 0.08 times 4, that comes out to be 960. The interest earned is $960. The maturity value, or the ending balance, MV, is equal to the principal plus the interest. So for this one, that's going to be the 3,000 plus the 960. So at the end of your 4 years, you have $3,960. They generally do not use simple interest for things that are 4 years long. Usually they only use simple interest for things that are less than a year, usually less than 6 months even. So let's look at, let's say you invest $7,200 at 6% for 4 months. So I want to find how much interest you have and what it's going to be worth at the end. So your interest is going to equal your principal is $7,200 times your rate. I'm used to putting the rate in parentheses just to make it easier to keep it straight instead of putting the X's in or dots that I might get confused with decimal points. 6% is 0.06 as a decimal. Now we said our time is already in years. So to express 4 months in years, it's 4 over 12. So now we multiply this all out. I think it's $360, but I'm going to double check it. Oops, $144. Good thing I didn't guess on that one, huh? So yes, $144 is our interest. That's our interest. That means the value at the end, the maturity value, is going to be the 7,200 plus the 144, or 7,344. So this is if you are investing money in an account or if you're borrowing. I have run a construction business on the side when I'm not teaching. It's not uncommon for me to have to take out a short-term loan. For example, I might be in the middle of a large project where I don't have a check coming in until I hit the next stage of the project and I have to make payroll for my employees. I may go to the bank and say I need a loan for 2 months or for 60 days or whatever. So let's say I'm going to borrow $10,000. They're going to charge me, so they're charging me 5% for 2 months. I'm just using 2 months so it keeps it a little simpler here. So the amount of interest I'm going to pay here is $10,000 is my principal. 0.05 is my rate, 5% written as a decimal. 2 months is 2 over 12. Now this is going to be an ugly decimal. So it's 10,000 times 0.05 times 2 divided by 12. Gives us $83.33 is my interest. So at the end of that 2 months, I'd have to pay back the $10,000 plus the 83. So that's $10,083.33. Now, like we said, anything more than a few months, at the very least anything more than 6 months, they don't use simple interest. They would figure in interest as we go. It's compound interest is what that's called. Where they calculate the interest and they add it into the account. Most people think compound interest is the most commonly way things are done. Believe it or not, simple interest really is the most common way interest is calculated. The reason for that is most accounts have a payment scheduled every month. For example, if you get a car loan, that is actually calculated off of simple interest. They only calculate the interest on your car loan when you make a payment. So you make a payment, they calculate the interest and add it in. The only exception to that is if you go more than, I believe it's more than 90 days past due on a payment, they'll calculate the interest and start compounding on you. But that's a different case. A standard auto loan is simple interest. They calculate the interest every time you make your payment. So if you make your payment early 1 month, there'll be less interest than if you make the payment late the next month, there'll be more because it's a longer period of time. So anyway, compound interest, they will calculate the interest out every period and add it into the account. So that might be done monthly. So it's done once a month. That's probably the most common anymore is monthly. Quarterly used to be the most common. That's 4 times a year. Or every 3 months. Biannually, meaning twice annually. That was every 6 months or 2 times a year. That one's hardly ever used anymore. Some of the larger banks do daily compounded interest every day. And there's a trend out there to do continuous compound interest. The continuous compound interest gets to be a complex formula that's done with the computer. Okay, we're running close to our time here, so I'm going to throw up here your homework for the weekend. Page 36 through 37, 1 through 51, the odds, deals with percents. We'll talk about this compound interest a little bit more on Monday, and then we'll finish off with Roman numerals on Monday. Wednesday will be our Unit 1 test. You guys all have a great weekend.